All right. Good morning, everyone. Welcome to Autodesk Virtual Academy, brought to you by KETIV Technologies. It is a happy Thursday here in Brea, California. I would like to welcome you all to today's session. I'm Nigel Mbayak, one of the customer success managers here at KETIV. And today I'm joined by a couple of people. First off, the man, the myth, the legend, Adam Evangelista. How's it going, Adam?
Oh, not too bad. Falls in the air and in my drinks. Glad to be here once again. Thanks for having me.
There you go. And we have we have our good friend Alex Alvarez here in the background. Alex a little far from the microphone. Alex, just wave to the people.
There we go.
Awesome. I'm really excited for today's session. We're going to be going over some AutoCAD Electrical. AutoCAD Electrical is one of the most requested things on this channel. We do a lot of Inventor. We do a lot of Vault. A lot of people use AutoCAD Electrical, and we want to be able to show you guys more of it. So that's why we brought Adam and Alex in here today. They are some of our instructors for AutoCAD Electrical. So they're probably some of the best people to go ahead and talk to us about it today. Adam, do you have anything else to add before we get started here?
No, feeling good, man. Yeah, it's a good day for warm drinks, and a good day for AutoCAD Electrical. Let's get going.
All right. So if anyone has any questions, go ahead and type those into your respective chat and questions panels, and we'll make sure we get to them. And with that, we'll go ahead and get started. So Adam, take it away.
Cool. Thank you, Nigel. Right on. Just a quick little agenda for today. We're going to go over some quick introductions right now, talk a little bit about the agenda, of course, and kind of do a bit of canvassing over here. The main meat of today is going to be talking about point-to-point versus ladder. You'll see in my presentation and inside of my documents over here, I am going to be abbreviating point-to-point as P2P. I know, advanced stuff, just be on the lookout for that. So we're going to talk a bit about the nuances between ladder schematic diagrams versus point-to-point schematic diagrams, specifically the settings and drawing configurations that come along with some of that stuff. And then the examples that we have are going to specifically talk about, focus on parametric connectors and some of the wiring tools that are available and usable inside of those environments. And we have some sample drawings set up, and we'll walk through a simple one towards the end as well, followed by a quick review and Q&A at the very end as well. You'll notice on the right side of the screen is a regular ladder and a connect the dots puzzle. Next slide. Just a quick little introduction. Again, my name's Adam Evangelista. I am an application engineer here at KETIV Technologies. We do sell applications here at KETIV, not just AutoCAD now, but also the whole Autodesk suite, and including ANSYS simulation solutions as well. So as application engineers, we specialize in those particular tools, and we try to help you guys utilize them to the best of your abilities and to ours as well. That's what I'm here for. In particular, we wear a lot of hats here as application engineers. In particular, I focus on the Lifeline team. I do a lot of the support and hotline support over here. So if you guys ever called in for licensing, how-tos, errors, installations, and the like, there's a good chance you probably talked to me already or someone on my Lifeline team, our Lifeline team. In addition to frontline support, we also do training. So I do some of the training, for example, for AutoCAD Electrical, Inventor Professional, AutoCAD. But this also includes the Jumpstart training from our Streamline SKUs more recently. But if you guys have ever been in our Jumpstart sessions, we also do monthly beginner-friendly sessions to get you started in Inventor Professional, AutoCAD, and Vault. And at this point, right, we're pretty knowledgeable on various subjects now. I know a lot of Inventor Professional. I know a lot of the Vault Professional recently as well. So if you have data management, let us know. And of course, the AutoCAD platform is wide and varied, but we're also pretty knowledgeable in that as well. So feel free to reach out if you have any questions. AutoCAD Electrical has like some workflows to Inventor, for example. And so there's a lot of different connections to the different parts of the software in the Autodesk solution. So just let us know what you're trying to do, and we're happy to find you a solution within our suite, okay? Then finally, just a bit about my personal background. Before this job, I went to college. And after that, I spent some time working at a makerspace down in Los Alamitos, which was a pretty good time. If you're not familiar with makerspaces are essentially community-run workshops. And so we have a bunch of manufacturing techniques over there, things like CNC machines, laser cutters, 3D printers. We would help people come in there and they would have their crazy ideas and we'd have to help them make it. It was a lot of fun. It was a good time. I learned a lot. And it goes without saying, but you know, I like making things as an engineer, but more than that, I like helping people make things as well, you know. So that's what I did at my last job. That's what I'm doing here today. And yeah, I hope hopefully we could help you guys get to where you need to. So let me know, and glad to be here. Okay, so let's get into the meat of this. All right, so looking at the list over there, we do have quite a few customers. We get a lot of questions about AutoCAD electrical. Um, and one of the common questions is just point to point versus ladder. You know, what's the differences? Why do they exist? Why are they there? And on screen right now, you see an example of both. On the right is the, I don't want to say more traditional ladder diagram, but that is a ladder diagram. Called so because it looks very much like a ladder with these big vertical buses along either side. And then you see these individual rungs that kind of have these kind of self-contained circuits that represent various things. Here on this particular ladder diagram, you see this motor control relay and a few buttons that connect all together, and that kind of represents a single step of the ladder, right? And that's great, that's fine. And then on this other side is a P&ID diagram from the sample files that we have in AutoCAD Electrical. This is point to point. You see it doesn't look like a ladder specifically and is more about connecting the individual objects to other objects, right? So it's not necessarily as strict or anything like that, but yeah, we'll talk about some of the nuances between that, but I just wanted to get a clear idea of what we're looking at over here. AutoCAD Electrical is all about making schematic drawings and panel drawings, and you have a choice between point-to-point or ladder diagrams in terms of your stylings, and it's largely up to preference at the end of the day. But let's talk a bit more about that, shall we? Point-to-point and ladder are not mutually exclusive. First of all, let's say that. Okay, we get a lot of customers that start off in ladder and then they don't necessarily know how to approach point to point, and so they never really make that jump. But again, they share largely all of the same tools. As far as I know, the spreadsheet to PLC I/O functionality is the only one that's dependent on a ladder diagram setup. But everything else, like the wire editing, component editing, placing, all that stuff, the reference system specifically, those are all largely the same in point-to-point or ladder. So if you're worried about switching over and not having the full functionality, you shouldn't need to worry about that unless you do some of the spreadsheet to PLC to I/O. That said, oftentimes most projects use a mix of both in the first place, and so there's no reason why you would decide to use ladder on a project and then just exclude point to point entirely. You could use a mix of both and present them as you need to. That said, ladders are again a bit more abstract, and I'm speaking at a bit of a higher level over here. But ladders specifically, they tend to be a bit more abstract and they tend to be a bit more logical. So they kind of represent an earlier step in the electrical schematic design, where you're just kind of getting early on. You want to get a good understanding of these circuits and the logic behind it, right? And ladder diagrams, of course, have a close connection to ladder logic and PLC controls specifically. And that's kind of the intent for ladder as part of this design process and this high-level interpretation. That said, not everyone knows how to read ladder diagrams, and not everyone in the manufacturing and implementation of your electric schematic diagram will know how to read ladder diagrams. And so this is kind of where point-to-point comes in. Point-to-point still represents all of the same information, right? These kind of electrical connections, but it tends to be a bit more literal, a bit more physical. And the example I have on this page, for example, is a P&ID layout. And so you could imagine an actual factory floor layout with these point-to-point connections, just kind of representing how product flows from one point to another point in the processing. Right. So if you were like a technician on the floor doing assembly, for example, you wouldn't necessarily need the ladder diagram. It might be more beneficial to have the explicit connections listed out point to point as opposed to in a abstract ladder configuration. Okay. And it goes without saying, but point to point is technically a bit more flexible. So you could kind of have a bit more control over how your drawing looks and how it's presented, and looks a bit nicer and gives you a few more options ultimately at the end of the day. Again, a mix of both is probably the preferred solution at the end of the day. If you ever need anything, you'll probably need a bit of both to get a good project out anyways. It just depends on the different levels and different audience that you're going to be presenting these drawings to. Okay. Any questions about point-to-point versus ladder? Again, I'm presenting them as largely the same, and just the kind of philosophy behind it is kind of the main difference behind them at this point. Okay. Right on. Let's keep going over here. Right on. Right on. So that said, let's go ahead and jump into AutoCAD Electrical then, shall we? Let's see what's going on. What's the whole big deal about this AutoCAD Electrical, shall we? Okay. Okay, and so I have a project set up here already, this October AVA.ACADE.point-to-point. And I have these point-to-point examples that I mentioned earlier already. This is the P&ID one that I used from my presentation. And so if you look at this guy, right, this is a P&ID layout. You see various things like grease tank over here, conveyors, mixers. And this is, again, just kind of meant to represent a factory process, right? This is AutoCAD Electrical, but clearly this is just P&ID, right? So they're not necessarily one-to-one. Like you don't need the intelligence of an AutoCAD Electrical drawing here, but I do like to kind of emphasize the fact that AutoCAD and the whole AutoCAD platform is a drafting platform. It's all about drawing, and you could technically use AutoCAD to draw these same exact diagrams if you really wanted to, but you would be missing some of the higher intelligence of these components. If I right-click, edit components, you get all this extra information for reporting and bill of materials down the line as well, right? So it is still a drafting program, and what we're doing ultimately is connecting, points to point ultimately. But AutoCAD Electrical lets you kind of configure all these extra component tags and all this extra information along with that as well. So that's one of the benefits of going into AutoCAD Electrical. This is P&ID, which I'm showing over here, but hydraulic and pneumatic components are also available in AutoCAD Electrical, seen here and here, right? And those are really nice as well. And so there's a pretty good library of either of those guys, but we don't get nearly as many questions about those for as we do about electrical, naturally. So that said, let's go ahead and go into our first drawing right here. What I have on screen right here, this is a point-to-point drawing with line references with no bus, okay? What did I say right there? So one of the first things we need to do when we start these drawings is make sure we set up our drawing configurations properly, right? And that largely is going to mean that we need references. I feel like when I first started point-to-point, like I feel like I didn't need references. I didn't want to set up references or anything like that, but very similar to ladder, you're still going to need a reference scheme by and large for what you're going to be trying to do here. So in this case, my point-to-point drawing here has a linear reference scheme. And if we take a closer look at all these guys, I have my kind of similar to the ladder logic where I just have the references going along the side over there. Each of my wires and components are going to be referencing that stuff over there. Notice that these don't line up as cleanly as they do with a traditional ladder placement, right? I have this wire, for example, that's kind of hanging out in between 2 and 3 right here. The zones specifically are, again, just going to kind of be above the number up until the next one. So everything above 3 and below 2 represents zone 3. And if I keep going along that same zone, if I have another wire, it's going to add a suffix for A. So zone 3, first wire, the next one is going to be 3A, and we just keep going down there for all the different line segments. Same is going to apply to our different components as well. So circuit breaker 3 right here, that is a linked component, so it's only going to have one component tag along this. So circuit breaker 3 is in zone 3, limit switch 3, 4, and 5 also represent these guys as well. And yeah, if we go down here, we can take a closer look at some of the other wires over here. Again, notice that the same wires, the horizontal wire segments, 12, 12A, 13, 14, and stuff like that. And I have a circuit relay right here as well. And so that's circuit in zone 12, and the normally open contact is in zone 14. And over here, we see the same component tag for the child component and referencing the zone 12 parent, okay? Same thing with PLC. I don't have too many components on this particular drawing, but I just kind of wanted to emphasize how the reference system is still going to work exactly like you'd expect it to, even though you're not using a ladder reference, okay? And before I leave this particular drawing, let me just say, normally when we start a ladder diagram, right, the first thing we do is insert a ladder. But in this case, since we don't need ladders, since we're doing point-to-points, we could simply choose the no bus option right here. And that's just going to give us this long list of linear references along the side. And so again, like when I was learning this initially, like I always thought it was kind of strange that people talk about ladder diagrams, and ladder kind of refers to the specific format you present the drawing in. That's separate from the actual reference scheme. So ladder isn't a reference scheme. Ladder is just a way to organize your drawing ultimately. when I say ladder diagrams use linear references. So that's what happens when you place down a ladder for the first time, is you place down a linear reference, which is what we get here for these numbers along the side. But just a heads up, that's what happens when we put down a ladder with no bus, okay? So this is a point-to-point drawing with linear references and no bus ladder, okay? Looking pretty good. Any questions about this so far? Cool, feeling good. Next up, this next drawing over here, this is point-to-point XY zone. All right, so same thing as before, right? You could choose various configurations for your referencing. Most common is probably the linear ladder referencing, like we were saying earlier. But kind of more relevant for some of the point-to-point stuff, right, is maybe you want an extra dimension for locating your components, which is where XY zone comes in as a referencing scheme. If you're not familiar with XY zone, right, it essentially demarcates different XY coordinates for your different zones over here. So along the top, I have the alpha notation, A, B, C, and D, all the way to the right. And then I have the numeric ones going down. And if I look at any of these components, right, they exist in a particular zone, and we'll get those reference tags accordingly. So for example, this wire has the start point in zone 1A, A1, my bad. And so this wire number is going to be the reference, which is A1, okay? Same thing for circuit breaker, right? Circuit breaker dash zone number. And then, you know, B1 over here starts in this section. That's going to be B1 over there. And same thing for contact relay as well. No big changes there, nothing too crazy. Again, you could do this with a ladder if you really wanted to, but in this case, point-to-point makes a lot of sense and interacts with XY zones pretty easily. Making sense so far? One question we do get, and one question I always ask, was when we do the drawing format, right? I could right-click, properties, drawing properties, and go to drawing format. And format referencing is going to be where I decide what kind of reference scheme this particular drawing uses. And again, it's good to note that drawing properties are going to be separate from the project properties. Project properties represent a default, which you can apply to drawings, but my individual drawing formats I could set per drawing as well as needed. So most common is going to be the XY grid and the reference numbers, which is the linear. X zones, we don't see a lot for whatever reason. I'm not entirely sure why, but X zones would be the same thing as XY grid, except along just one dimension instead of two. So not unlike the ladder diagrams, but in the opposite direction. And if you ever need to, how I place these specifically, right, I went ahead, I clicked setup, and you're able to pick the origin for where this part starts over here. And you're also able to choose the spacing. 2.0 is the default, and honestly, it looks kind of small in the sample, but I did that just so we could kind of highlight the differences between all the components and stuff like that. And down here, you could also format the actual separators and stuff like that for how it's going to show up. So do you want it to show up as an XY tag or a YX tag, and do you want a separator between those two? You could configure that here as well. Okay. And so again, it's very similar to ladder diagrams so far. Like, it's still going to kind of rely on the reference scheme that you choose. But XY zone just gives us a bit more information about where these parts are located at any given place. Okay. And then finally, we have point-to-point no reference. I should also probably name this sequential as well, but you'll notice that there isn't any sort of reference scheme on this particular drawing. And so I had a customer recently that was really interested in going to sequential specifically. They'd done all their drawings and point-to-points in AutoCAD, and now they're moving to AutoCAD Electrical, and they want to do point-to-point, one, and two, they wanted to settle on sequential specifically. The sequential is simply going to count off the individual components, right, without a particular spatial reference, like with the ladders and zone referencing. In this case, right, you just have the wire segments counting off 1, 2, 3, 4, 5, 6, and then the components themselves are going to be acting that way as well. The only real place where this breaks down when you're going to point is the sheet referencing or the cross-referencing specifically. So I go ahead and right-click properties, drawing properties. Notice that components, I could have the default tag right here, which is %S, %F, %N, and that's going to be the typical one. And depending on your reference scheme, like line and XY zone, that's going to fill out accordingly to that. But when I go ahead and end up with, oh, sorry, let me take a step back. So before I get too far, right, the default component tags, they use line referencing. So when I say line referencing, it's going to go ahead and refer to the drawing format referencing that I put down initially. And in this case, for this drawing, since I don't have any references set up, I'm going to actually bump it to sequential specifically. So what sequential means is that it doesn't have a reference. So this %n term actually drops out and it shows up blank. And so the way that my tags for my components are going to start showing up are going to be %f, which is the family. And then it's going to be followed by the sequential increment. Okay, so not an actual reference to lines or anything like that. So just %f, the family name, and then the sequential number. Okay, and that's why I have things that look like circuit relay 4, circuit breaker 4, limit switch 6, 7, and 8. Okay, so that's why that looks like that specifically, because I set these all to sequential. And again, it's just as easy to switch to sequential as it is to line referencing. All I did was select sequential and chose a start point for my sequence, okay? That said, the only place where this kind of becomes problematic, right? So again, notice that the format %n drops off. I'm leaning on the sequential instead. And now we go to cross-referencing, right? By default, this shows up as %n, and you also have the option for %s, %n. If you're not familiar with replaceable parameters, right, the %s refers to the sheet number from the title block, and then %n is again supposed to represent the reference tag that shows up in your reference drawing. Okay, but in this case, right, since I'm doing point-to-point with no reference scheme and I'm doing purely sequential, I don't have a way to cross-reference the %n to another part of the drawing or project. In this case, what we recommend and what I've been told about is that people go ahead and just put in the sheet number themselves. And so that's why I have just %s right here. Go ahead and click OK. And if I go to my drawing properties one more time, drawing properties, I have my sheet number set to just sheet number, just like that. If I go down here, I was writing own text over here. And to update this, I've been going ahead and going to parent sibling, going to contact relay, going to OK. And that's able to update this just like that. Okay. And so again, the control relay right there, we have normally open sheet number and then own text. That was from some testing I did earlier, but let me see if I could fix that right now. There we go. All right. So again, so that's again just the cross-reference specifically, right? It's meant to kind of locate the other part of the child or parent somewhere else in the drawing or project. Since we're doing sequence, no reference, if you want to do that for your point-to-point diagrams, it means that we're going to have to be a bit smarter about where we place our sheet numbers and how we represent that, that reference. So that's the only real big gotcha if you want to do no reference sequential, is that the cross-referencing needs to be adjusted a little bit. So that's the only thing there. But otherwise, you could go to sequential without much issue, and you could go to no reference without much issue, as long as you look after your cross-referencing right there. Okay. And notice I do have format referencing still checked down here. That's there if you ever need it. Like once you place down your referencing scheme, like your ladders or your XY zones, that's when these %ns will start showing up again if you have it set to line reference. Okay. Okay, so any questions so far about reference schemes or anything like that? As far as point to point goes, right? That's kind of what you're looking at. Again, I used to think people just didn't want to use reference schemes for their point to point, but it's pretty recommended to still choose a reference scheme. So probably the first two formats are what I've been told are preferable, but looking good, looking good. Okay, and so again, I made up the circuit last night, and we just it's pretty simple, nothing too crazy. Some circuit breakers, limit switches. We have a PLC module down here to contact relay, and we're just going to go through for the last part of this presentation and describe how we kind of went through this and made this. Okay, cool. So let's go to point-to-point demo. I'm going to go ahead, and this is a fresh drawing in my project, and I'm going to go ahead, right-click properties, and I'm going to make sure all my drawing properties are set up as I need them to. Okay, nothing too crazy over here. I'm going to keep my, I don't know, what type of referencing do you think we should do, Nigel? Should we do line referencing or should we do the XY zone referencing?
Why don't we just use X?
Just X zone? I don't think we're going to do that.
We can use XY. That's cool.
Let's go ahead and do XY. So again, for the XY referencing, we don't need to change anything for component. We are going to keep it on line reference. Same thing for wires. we're going to keep the %n and the line referencing. Nothing changes. And then for cross-referencing, again, nothing changes here so far. The only thing I'm going to do, I'm just going to go ahead and change the XY grid. I'm going to go ahead and choose my setup right here to make sure I know what I'm doing. And for here, we have the origin, right? So again, this is the XY grid setup right here. I need to pick the origin for I want everything to start, maybe around here. And that's going to put in this information itself. Maybe let's go ahead and make this like 3.0, 3.0. And then for the XY formats, I don't want to put a separator between the XY format. I think that looks a bit clunky. So I'm going to actually minimize that so that there's no space between the X and Y. And so when these component tags show up, the %n is just going to be represented by the A and the 1 right next to each other, or whatever zone it's going to be in. All right, go ahead and click OK. I'll talk about tag order at the end of this drawing, but in particular, well, I'm setting it to no override for now, which is by default left to right, top to bottom for tag order. Okay, we'll talk about that in a little bit though. And now I have my referencing zone set up, but I don't actually have my little demarcated notes along the edges. So I'm going to go up to my ladder, place ladder function up here, and I'm going to go to XY grid setup right here. Notice it's going to pick up the origin that I've picked up from the drawing properties already, along with the spacing and the XY format and all this good stuff. And I'm just going to go ahead and insert XY grid labels. So let's do a 10 count off the top and then a vertical count. Let's just do 7 for now. Should be plenty. And notice that you don't have to choose the negative over here. I think, yeah, you don't have to be negative. It's just the absolute value of the spacing over there. So you don't need to do like a negative growth down or something like that. Typically, you would set up these XY zone borders in your actual title block or in your drawing template in the first place. So I think this looks kind of rough, and I chose 3.0, and that just overlaps just a little bit. But that should be fine for us regardless. Let's go ahead and get started. I'm going to go ahead and place in a PLC, right? So this is the Parametric PLC tool. Right, and this just helps me place in some regular out-of-the-box ones over here. I'm going to choose the horizontal module. It doesn't really matter what you choose. I'm choosing this one just because I know that it has 9, and 9's a nice round number for what we're about to do right now. I'm going to go ahead and click OK. I'm going to place it right there. Cool. And again, you could choose some of the model. I'm going to leave it all default over here. No big deal. Now we have this nice little part to start right there. In addition to that, I'm going to go ahead and place some connectors down as well. So connectors are kind of just a general thing. These are parametric connectors specifically. And these are just kind of general components that you could use to run connections off of. If you see the little preview right there, you have a plug on top and a receptacle on bottom. And then you're going to be able to run wires off of that while kind of denoting what the pins are and what the wire numbers are right there. Okay. The pin spacing, I'm not terribly worried about, but you do have the option between fixed spacing or at wire crossing. I'm going to go ahead and keep it at 0.5 for now. So I'm going to ask it for fixed spacing right here. I'm going to go ahead and leave the pin count at 3. You have an option between insert all and allow spacers and breaks. I'm not going to talk about, well, we might talk about spacers and breaks later, but I'm going to do insert all for now. And then you also have the pin list right here. You could demark if you want this to be alphanumeric or if you want it to count off odds or evens or what have you. In this case, I'm just going to leave it alone at 1, 2, and 3. Okay. And in particular, down here at type, you get some more ways to configure these connectors. Is it going to be plug/receptacle? Is it going to be plug only or receptacle only? I'm going to go ahead and do a receptacle in this case. And then over here in orientation, orientation and display are the same things in this case. But I'm just going to rotate it a little bit so it's upright, and then I'm going to flip it to the other side so that the wires are coming off the right side over there. Okay, and then you could further adjust the sizes if you wish as well, but I'm not going to do any of that here. I'm going to go ahead and insert. I'm going to maybe just place it right around over here. Very cool. I don't need anything right here quite yet, but looking pretty good so far. And then I'm also going to run a multi-bus off the top as well. Again, spacing is not terribly important here, but you could set it up to be whatever you want. I need this to be empty space vertical, horizontal, so it's going to be running off the top for me. Okay, I'm going to go ahead and run it at 3 wires, go ahead and click OK, and that's looking awesome. Okay, well, let's put that a bit further back actually. Something like this. Okay, so now we have kind of like this little three-phase power bus off the top. We have a connector down here, and let's see, I think we also need a connector at the bottom and over here as well. So let's just do that as well. I'm going to insert another connector. Again, nothing major changes over here. I'm just going to flip this up, and I want this to be a plug this time, for example. Totally fine. And the connections are going to come off the top right there. Maybe we change this to like A, B, and C instead. And it will pick up the pattern automatically. So even though I don't put in B and C, I could just put in A. And I'm going to do fixed spacing, insert all. That's totally fine. No more down here. Okay, cool. So now how do we go about connecting all these suckers together, man? Well, first things first, let's go ahead and insert a multi-bus connector. Yeah, I believe with like ladder diagrams, right, you have like the rung tool and stuff like that to kind of accommodate for these wires and stuff like that. In this case, we're going to be a lot more explicit and a lot more precise about the actual wire placement ourselves. And so we have the regular wire tool, of course, which will allow you to connect anything that you want. In this case, we're going to make a special use of multi-bus in particular, because that's really helpful for us. If you've never used the other functions of multi-bus, you could also run multi-wires off of components specifically. The one I made originally is from empty space, and that allowed me to click over there. But you'll see that if I go ahead and go to components, right, multi-wire, I'm going to go ahead and click OK. It's not going to allow me to draw just anywhere. It's going to want me to highlight some of these connections that come off of these AutoCAD electrical blocks. Okay, and that's another kind of special feature of AutoCAD electrical blocks, is that they have these connections that will allow you to make placing multi-buses a lot easier. So in this case, there's 1, 2, 3. I'm going to do a window select for these guys. They turn into a red diamond. Right click to start the process, and you're off to the races. You'll notice right off the bat that the spacing for the multi-bus doesn't look that close to what's on my PLC. Well, that's okay. What we're going to do, we're just going to try it anyways. Okay, and you'll see that the multi-bus automatically resizes itself to go ahead and connect to those that spacing automatically. Again, it's kind of flexible. You're not kind of tied to the rungs on a ladder, for example. I could just go ahead and place this multi-bus down just like that.
And that's kind of one of the benefits too to AutoCAD Electrical, right, Adam? Is, you know, a lot of customers, they use AutoCAD to do some of the electrical schematics. So that's not too uncommon. But this is just one of the huge benefits to AutoCAD Electrical, is the automation and some of the intelligence that's kind of built into the software itself.
Yeah, the program really wants to help you, and some of the nuances can be kind of challenging for sure, but little things like this help save you time as opposed to, you know, scooting around lines in base AutoCAD, for example. So that's great, right? I just placed these guys, the connections were there for me already, and it spaced itself automatically. Like, that was a good time. I'm having a great time. And that's about that for this particular connector, right? And let's see what it's like to insert a multi-bus from we need power for this poor PLC still as well. So let's go ahead and see how that goes. Again, keeping track of my starting at options over here. If I choose component, it's going to want to find electrical components in those connections. If I choose empty space, it's going to want to go off of empty space. But if I choose another bus, it's going to allow me to place one off of another bus. Okay, just like this guy up top. So I'm choosing the top wire right here, and it's automatically pulling down and stepping those wires down as well. And you'll notice if I want to go straight down and like place these guys right here, it's not going to resize automatically. Again, that's just kind of a quirk of the software. I usually need to at least go a few steps out for it to go again. So what I'm going to do here, right? I'm running the multi-bus. I have it here. If I pull it to the left, it's going to keep moving my wires that way. If I pull to the right, it's going to overlap and go that way instead. That's totally possible. And if I wanted to keep one of these steps, right, I'm going to have to look at my status bar at the bottom over there. Notice that we have two options. We could either input C for continue, or we could press F for flip. Okay, so let's just try flip first of all. What does flip do? If I press F and space, it's going to automatically kind of wrap those wires around to kind of look different. That's a purely aesthetic choice, but that's what F does. Right, and I could input F space again to have it flip back and forth. What C does, C allows us to kind of save our current position. So let's go C space. It's going to allow me to kind of continue my ladder with this little extra bump inside of it. Okay, just like that. And so, yeah, you could get pretty crazy with this, but C and F allow you to kind of configure this and wrap this around and navigate around your objects as you need to. Again, this is not something you would typically see in ladder diagrams, although it could help, but in this case, this just allows us to navigate and be a bit more flexible with our wire placement. I'm going to start over again because I don't need that many kinks in there. I have plenty already. I'm going to go ahead and start this right here one more time. I'm going to run 1C. So, maybe, yeah, I'll go and give it an F. Well, no, I'll keep it like that. Then I'm going to put down another C right there so I can come down again. And you notice this time when I want to connect down here, it's going to automatically resize those wires automatically so that it'll be able to fit into those pins. Again, that's just kind of a quirk of the software, right? The initial placement of the multi-bus doesn't end up getting spaced out automatically. You have to put in a few turns in the wire so that it knows a bit better, okay? I'm going to go ahead and click, and it's going to fill that in for me. Again, noticing that the wire connections also update with these little like overlaps and dots. Good stuff. That's the dream. Again, it'd be a big pain to do this in AutoCAD base if you wanted to, but that's part of the reason why we're in electrical. So now the PLC has power, it has a receptacle over here, and I want to connect these last 3 connections down to this guy over here. So let's see what that's going to look like. Multi-bus. I'm going to choose component again. Again, noting that when I choose component, it's going to automatically want me to choose the connections on my AutoCAD electrical blocks. So I'm going to mouse over these guys. Awesome. I think it'd be nice to make it look overlap just to kind of distinguish it. And I'm going to pull out another C right there, another C, put in an F, another C right there. Gorgeous. Look at that. See, that wasn't so bad, huh? Look at that. Cool. And so, again, just going through that, that's kind of what you expect from working with not just multi-bus, but regular, yeah, no, that is multi-bus specifically, but just going through the wire and trying to navigate around certain objects that you want to. That's what we're going to end up doing, okay? I didn't talk about connectors too much, but there is some extra functionality. For example, I had fixed spacing for the 2 that I placed initially. At wire crossing is also really useful too, though, so I recommend checking that out. I think I could do a quick one here, hopefully. We have at wire crossing. It's going to be, doesn't even have to be the exact number of wires that we have. I just want to kind of demonstrate how smart this tool really is. Pin count is 4, right? So we have something like 4. And I'm going to do a plug and receptacle right here. So let's say a plug is coming out of these 3 ports from the PLC and it's connecting to another receptacle from something else, maybe like an extension or something. Again, the main change that I made here, increased the pin count and made it so that the spacing isn't going to be fixed anymore. Here, it's going to be at wire crossing. Okay, let's go and insert this bad boy. Again, since I set it to at wire crossing, it's going to automatically want to resize itself when it's over a bunch of wires. Okay, so you see there, there's kind of 2 images there. So there's the resize and then the true size. I'm going to put it right here in the middle. Okay, oh, right there. It's going to automatically fill that in and want to automatically populate itself just like that. So notice that the wire crossings are going to automatically adjust itself to show up there. In this case, I placed it a bit to the left. So the first pin, the A pin, got moved to the side. And then the B, C, and D are the ones that ended up getting the connections for this parametric insert right here. Okay. And so, yeah, the connections are really great. And again, there's just kind of a lot of this flexibility, right? I can either place the connectors first, I could place the wires first if I want to, and I could go back and I could insert them with a lot of extra flexibility and intelligence, okay? Okay, and so, yeah, any questions so far? That's kind of the bulk of it. From here, it's gonna be a lot of like traditional placing and schematic placing, okay? Oh. Right on. So yeah, I'm gonna go here. I'm just gonna go and place some of the last couple of components over here. Again, nothing really changes when we're going into the actual schematic component placement. It's all gonna be the same, and the main thing to take away is just how the referencing changes in point to point. So for example, let's go ahead and do the limit switches really quickly. So over here, let's see, limit switches, where are we? Limit switches right here. Go ahead and do one of these guys. I'm sorry, let me take a step back. Instead of doing the regular, single place, I do want to highlight the fence insert, the multi-insert one. So multi-insert, if you guys haven't used this tool, it's fantastic. All you have to do is select your component, right? And then you can go ahead and draw a fence onto the multiple wires that you want to cross in place, right? I'm being a bit exaggerative right here, but you can see it's going to cross at all these points. I'm going to go ahead and right click. It's going to give me the option to keep this one, keep all, don't ask, do whatever. I'm going to go ahead and just keep all and don't show the edit dialog box. Okay, go ahead and click OK. All right, and so these limit switches come in along the multi-insert fence that I placed at the beginning, and from here I can go ahead and align here, here. I'm going to go ahead and OK to retag. And again, the reason why it asked me to retag is because my limit switch here was in zone D2, but now I moved it over to zone C2. And so the initial tag that I got when I placed it in is going to change because of the spatial reference. Okay, so that's why I got that message right there. But otherwise, right, nothing's really changing. I had the reference already, and these components are going to update accordingly. So limit switch C2, limit switch C2A. Again, C2A, the A is actually the suffix for that particular section to increase it, and then 2B from there. Okay.
Okay.
Right on. And so, I mean, we could place a few more components, but it's really going to all be the same from here. Any questions so far about how this goes exactly?
What's I have a question.
Yeah.
It's like, what happens if you want to like move some of the wires after the fact?
Mm-hmm.
Is there a way to easily manipulate where they go? I know, like, if you were to do this in base AutoCAD, you would just move the wires around. But say you wanted to move those wires that are on that PLC right there in slots 1, 2, and 3. Like, if you wanted to move those for some reason.
Like move them to another attachment point?
Either that or just move them off of there and detach them from there, move them somewhere else.
I see.
What's that process look like?
Honestly, so one thing about AutoCAD electrical wires is that they do just kind of represent regular AutoCAD sketches. And so like when I was preparing for this particular presentation, like a lot of my time was just deleting and redrawing the multi-bus, since it's so easy to redraw these. So that's one option, just delete them and draw them again, which isn't the best option for sure. But on top of that, on top of regular AutoCAD, you have all the other options for moving and scooting, for example. So if I wanted to move this connector, for example, I could still use the the scoot tool in this case. That's going to allow me to scoot this and kind of drag the wire connections along with it. There's certain things that do break, for example, like move component is going to, I believe, just move it away from those wires entirely. But that's kind of the intended purpose of move component. You're supposed to be moving it kind of like in a ladder diagram to another rung, and it's supposed to reconnect there. But in this case, right, I don't want it to disconnect, so I'm just going to do that. And from here, certain wires you can move and scoot like you would normally. So like this guy right here, you can move and scoot this up and down. You can move this guy, keep moving like that. There's just some things that I would probably just recommend to just redraw the wire. Like if I wanted to scoot this out even more, I would probably delete this connector, scoot all these wires out a little bit, or even redraw it so that I could just place it again. For example, I tried here and I tried scooting this guy. Yeah, so it's going to bring these pin connections along with it, but it doesn't carry along the connector, the actual connector stretch, for example. So yeah, that's what I would recommend at this point, is just that you can do the traditional wire movings like you normally would, like the scoot and moves, but typically I end up just redrawing them because it's not too much hassle, but you still have the scoot command and the move command to accommodate your component placement and wire connections. One thing I didn't mention about the wire bend is there's also a bend wire command as well. Oh, I'm going to kick myself because I forgot where that was.
I think that's everything, Adam.
All right, cool. Right on. Cool. Thanks for having me, guys. That was a good time.
Absolutely. Thanks, Adam. Thanks again, Alex, for hopping on into the AVA room and helping us with this as well. Everybody online right now, thank you all for sticking with us, learning about some AutoCAD electrical.
Yeah. Happy Halloween, everybody. Yep.
Oh, this was supposed to be on Halloween.
Yeah, it was.
So I guess happy Halloween. We'll see you all next week at 10 o'clock on Thursday. Take it easy, everybody.